Alright guys, today we're going to look at some more rational functions, and we're going to start off looking at some very similar to what we did the day before. So remember, first thing we want to do is, if we can, we need a factor. So I can factor the bottom of this. This factors into x minus 1 times x minus 1. And then after I factored, I can find my vertical asymptotes pretty easily. Those are when the bottom is equal to 0. So the bottom is equal to 0 at 1. Okay, so I'm going to go ahead and graph that. So I have my vertical asymptote at x equals 1. Then I'm going to go ahead and mark my horizontal asymptote. Horizontal asymptotes, remember, they follow those rules. So the rule is if it's heavier on the bottom, which the degree is higher on the bottom, because the degree on the bottom is 2 and the degree on the top is 0, that means that my horizontal asymptote is y equals 0. So I have a horizontal asymptote at y equals 0. Then I'm going to find my intercepts. So let's start with our y-intercept. That's when I plug in 0 everywhere there's an x, and that would give me 1 over 1, which is just 1. So 0, 1 would be my y-intercept. Then my x-intercept would be when the top equals 0. And if you look, that's not going to happen because it's impossible for 1 to equal 0. So there's no x-intercept. So then the last thing I need to do is actually draw this graph. So in order to draw this graph, what I need to do, or what I'm going to do, is make a sign chart. We talked about this before. I think it's just a little bit simpler to see our graph this way. So on my sign chart, I'm going to mark any x-intercepts, which there are none, or my vertical asymptote, which is 1. Then I'm going to pick some number to the left of 1. I already picked 0, and when I picked 0, I got a positive number. That means everything to the left of this asymptote is going to be positive and approach those two asymptotes. Then if I were to pick a number bigger than 1, say 12, I would get a positive 1 divided by a positive times a positive, which is going to work out to be a positive number. So that means everything to the right of 1 is also going to be positive and approach those asymptotes. So this one looks a little bit different just because at my asymptote, my graph is going in the same direction. And that is okay. And you guys have actually learned about that in Algebra 2. The reason for that is because that factor, that x minus 1 factor, is actually squared. And that's why it's going in the same direction. Alright, so now for this next one, again, I'm going to start off the same way. I'm going to go ahead and factor this. So that factors at the bottom into x minus 3 and x plus 2. So now it's pretty easy for me to find my vertical asymptotes. Those are at x equals 3 and x equals negative 2. So I can go ahead and draw my vertical asymptotes on my graph. For my horizontal asymptotes, I'm going to follow that rule. So this is a higher degree on the bottom, which means my horizontal asymptote is going to be at y equals 0. And then I can do my two intercepts. So my x-intercept, or let's do y-intercept first. My y-intercept is when I plug in 0 for x, which would be at 0, and it's negative 1 divided by negative 6. So that's 0, 1, 6. And then I can do my x-intercept, that's when the top equals 0. So this one's a little bit different because my x-intercept is actually on my horizontal asymptote. And that's okay because you can cross a horizontal asymptote. Horizontal asymptotes just kind of show the trend that your graph is making. It's not actually something that you can't cross. Vertical asymptotes are the only asymptotes that you cannot cross under any circumstances. So now to actually draw my graph, I'm going to make my little sign chart. And let me move that actually somewhere it's easier to see. Whoops. So I'm going to mark my vertical asymptotes and my intercepts. So I'll start by picking a number to the left of negative 2, like a negative 7. So a negative 7 would give me a negative divided by a negative times a negative, which would work out the whole thing, would be negative. So that means everything to the left there would be negative and going towards those asymptotes. Now the next section, in between -2 and 1, I already plugged in 0. When I plugged in 0, I got a positive number. So that means going towards my asymptote, it's positive, and going from 0 on, it's positive. Now I'll pick something in between 1 and 3, like 2. If I were to plug in 2 to that equation, I would get a positive number divided by a negative number times a positive, which means that whole thing would work out to be negative. So it means everything from 1 to 3 would be negative. So it looks a little bit different on the inside than what I'm used to. And then finally, this last section, if I pick a number bigger than 3, a number to the right of 3, like 10, that would give me a positive divided by a positive times a positive. So everything there would be positive. So there's my rational function. Alright, now the next question we're going to look at is going to be very different from something you guys have seen so far. Now if you remember, when we're graphing rationals, we said the first thing we want to do is factor. So I'm going to go ahead and do that. So the top, that's a difference of squares, factors into x plus 2, x minus 2. And on the bottom I have that same x minus 2 factor, which means that can factor out. Now, what happens when I cancel out a factor there, that actually creates something called a removable discontinuity. Okay, so if you cancel out a factor, okay, you get a removable discontinuity, which is actually it's a hole in your graph. We're calling it a removable discontinuity for something we're going to do later in the year. So anytime you cancel out a factor, that's what that creates. Now to find where that hole is actually going to be, the x value of that hole is you take the factor that you canceled out and you set it equal to 0. So in this case, the factor I canceled out was x minus 2, which means that my removable discontinuity, I take x minus 2 and set that equal to 0. That means that the x value is going to be 2. So that removable discontinuity has an x value of 2. To find the y value, what I do is I plug in that x value to the remaining function. Okay, so whatever I have left of that remaining function. So in this case, my removable discontinuity is at 2. My remaining function was x plus 2. So if I plug in 2, that gives me a y value of 4. So my hole, or my removable discontinuity, is at the point 2, 4. Now in order to graph this, what I actually do is I just graph the remaining function with the hole. And in this case, your remaining function can be a couple different things. It could be, in this case, it's just a straight line. Or it could actually be another rational function. It all depends on what you're left with. In this case, my remaining function is just the graph y equals x plus 2. And you guys learned in Algebra 1 how to graph that. It's just a straight line. So I'm going to graph y equals x plus 2. So I have a y-intercept of 2 and a slope of 1. But what's different about this graph, like we said, is it has that removable discontinuity at 2, 4. So all I'm going to do on my graph is at 2, 4, I'm going to make an open circle. And that's the hole, or the removable discontinuity. So that's what's going to happen if you cancel out a factor. So anytime you cancel out a factor, okay, that creates a hole in your graph. And all you do is you graph the remaining function with that hole in it. Alright, now the last one we're going to look at again is going to look very different than the other graphs we've seen. Again, to start, I'm going to go ahead and factor this. The top factors into x minus 5 and x plus 1. And the bottom's at x minus 3. Now there are no factors that cancel out, which means there are no holes or no removable discontinuities. But what I do have here, if you guys remember your rules, if I were to try to find a horizontal asymptote, I couldn't do that because there's none. So if you remember those rules, it said if the degree on top is higher, there's no horizontal asymptote. What there is, though, in this graph is a slant asymptote. And a slant asymptote works just like a horizontal asymptote. It's kind of what your ends go towards, and you can cross a slant asymptote just like you can cross a horizontal asymptote. The only difference is it's actually slanted. So the way we find a slant asymptote is by using long division. So in order to find what our slant asymptote is going to look like, we actually take the bottom of our fraction and divide it into the top of our fraction. So if you remember, for long division, we look at our first terms. X times x is x squared. I multiply x times both of those numbers, and I subtract the entire quantity. So negative 4x minus that negative 3x gives me a negative x, and I bring down my minus 5. X times negative 1 is a negative x, and I'll multiply that by everything. I would subtract that whole thing, and I would get a remainder of negative 8. Now my remainder is not really going to affect my graph. What really matters here is what I end up getting for an answer. That x minus 1 that I get is my slant asymptote. So what I'm going to do is, on my graph, I'm actually going to graph the line y equals x minus 1, and I'm going to make it dotted like an asymptote. So if you remember the line y equals x minus 1, that means it would have a y-intercept of negative 1 and a slope of positive 1. So my graph would have an asymptote that looks a little bit like that. So it works just like a horizontal asymptote. The only difference is it's slanted, and it's going to follow the pattern of whatever I get when I use long division. So that's my slant asymptote. Now the rest of this, it's following the exact same rules we've been doing all along. I can still find my vertical asymptote. I set the bottom equal to 0, so I have a vertical asymptote at x equals 3. And I can still find my y-intercept by plugging in 0 everywhere there's an x. So I get a y-intercept at negative 5 divided by negative 3, which is 5/3. So that's almost at 2, not quite. Then I can still find my x-intercepts as well. My x-intercepts is when the top is equal to 0, and the top equals 0 at 2 places. I'm going to have 5 and negative 1. So I'm actually going to go ahead and plot both of those. And this gives us kind of a clue as to what our graph is going to look like. You could still use a sign chart if you wanted to, but as you guys can see, I have to cross through those asymptotes, and I can't cross my vertical asymptote. So I'm going to have my graph go like this. And that's what my graph's going to look like. Alright, so slant asymptotes, you need to use long division to figure them out, but other than that, they work just like your other ones do. And that's all there is for graphing rational functions.